This section is going to cover 2.1 sets. We have a couple definitions. Our first one is that we have a set is any group or collection of objects. Okay, so pretty much anything you can think of that you can list can be written as a set. Our second definition has to do with elements. Elements are the objects or members that belong to this set. Okay. We use something called the roster method to list these objects separated by commas. So I'm going to go ahead and just jump right into an example just so you can see what I'm talking about. So in our example, we have that we want to use the roster method. So there's that roster method to represent the set of months. So the months that start with a J. So I did need to add for the roster method, we have to use these curly braces. Okay, so I want to make a note of that. Okay, so we're going to go ahead and do that first. So we're going to start with our curly braces, and I'm only going to do one because I don't know how long the list is going to be. So it says to represent the set of months that start with the J. So starting with January, that would be our first one. So January. Let's see, January, February, March, April, May, June. So June is the next one. And then we have July, August, September, October, November, December, and that's it. So we close our curly braces. Hopefully yours look nicer than mine. These take practice to get just right. That's better. All right, and yeah, that's it. So this is our answer for this first example. Curly braces, the elements inside, and we end with the curly brace. That's it. Let's go ahead and try another one. It says use the roster method to represent the set of class periods at Parkland High School. So we're assuming a normal schedule. So eight class periods. So we would again start with our curly brace. We have first period. You can even do it this way if you want. First period. We have second period. We have third, fourth, fifth, sixth, seventh, and eighth period. So this is your standard schedule. I know some of you have a zero or ninth period, but we're assuming the general population, okay? And that would be it. That would be your answer for this one. Notice that we do end and begin with those curly braces, and we do have commas in between each element, okay? All right, moving on. We're going to go backwards now. So let's say we want to write a word description for the set B. So this right here, just so we know, okay, what's going on here, this B represents set B. So this is like the name of the set. Okay, and in this set we have forward, center, guard, shooting guard, point guard. Hopefully you recognize what these are. I recognize them as the positions for a basketball team. So I'm going to go ahead and say that this is, so set B, because that's what it is the set containing or representing, okay, whatever you want to, whichever word you prefer, the positions, you could even say the playing positions on a basketball team. And hopefully I got them all right. That's what it was when I played anyway. So yeah, that's it. So set B is the set containing the positions on a basketball team. And these may vary depending on your description of what you see. But in general, it should be pretty much the same idea. Okay, so let's try another one, I believe. Yes, we have one more. Example, write a word description for the set H. So in this set H, remember this means the set H. Okay, we have Gryffindor, Slytherin, Ravenclaw, and Hufflepuff. If you're not familiar with this, you're just going to have to trust me on this. But these are the houses of the Harry Potter universe. So I'm going to go ahead and say that set H, write it a little bit different this time. represents the houses at Hogwarts from Harry Potter. You want to add that in case you don't know what Hogwarts is. Okay, so it just kind of shows you that we can do sets and descriptions of the sets for pretty much anything. If you're a Star Wars fan, you could even think of it as, what is the set of all the movies for Star Wars. So you could divide it by your original Star Wars, the prequels, the new ones, stuff like that. I'm not a huge fan, so I really can't list them all for you. I could do some, but you get the idea. Okay. Right. So yeah, that's pretty much it for what a set is. So we're going to go ahead and move on to some more different types of sets that we have dealing more with mathematics. Okay, you're going to have to bear with me a little bit on this one because there's quite a few. So some basic number sets that we have. And by the way, this is in your book on page 53. Yes, 53. In case you want to, just look at that one. It's a little bit neater, more condensed. We have what's called the natural numbers. So the natural numbers are pretty much your counting numbers: one, two, three, four, five, six, and so forth. It goes on forever. It's important to note that this one does not include zero. So you don't include zero for the natural numbers. Okay. The whole numbers, so that's the natural numbers. The whole numbers are pretty much the same as the natural numbers, but we do include zero. So some two differences between these two right here is that this one has zero and this one does not, okay? So just keep that in mind. Our integers are kind of like the whole numbers, but they also include the negative whole numbers. So integers are going to include every negative whole number, so -4, -17, -1,000, all the way to infinity, and your positive. So it's kind of like the whole numbers. So this one does include the whole numbers. Okay, it's a horror. I did not write that very nicely, but it includes the whole numbers and it includes the negative version of the whole numbers. Okay, again, all I'm doing is going over the different sets of numbers that we have in mathematics, the basic ones anyway. Okay, I'm going to go ahead and scroll down a little bit more. So these ones right here, and I'm going to box them up a bit. These two right here, the rationals and the irrationals, are a little bit special because we don't talk about them too much in high school, but they are one of the more basic number sets, okay? So rational numbers are represented by Q, okay? This is the name of the set, Q, and they're the set of all terminating or repeating decimals. I should say terminating, not termination, terminating, okay? So for example, I'm gonna kind of do this in the same color here. Let's say we have 1/4, okay? You know that 1/4 is equal to 0.25. And that's it. There's no other decimals here. There's no repeating, the numbers don't repeat. So this would be considered a rational number, okay? Now, it does say repeating decimals. The repeating decimals are the ones that stay the same. So for example, 1/3, okay? 1/3 is equal to 0.333, and it just goes on forever. So that 3 it's the same. It does not change. It just goes on and on and on and on. So this would also be a rational number. Okay. Now its counterpart, the irrational numbers, which I did in purple here or pink, whatever color you think that is represented by a cursive I. Kind of tried to do the cursive I here. It's kind of hard with the pen I have, but it's a cursive I. Make sure you don't confuse it with the integers. Remember, the integers is an I for integer, but this one is a cursive I, okay? So this is the set of all non-terminating or non-repeating decimals. So in other words, um, let's say I had, I'm going to pick one of the more popular ones, the number pi, okay? pi is approximately equal to, because it's not equal to, 3.14926, and I don't know what else. But it goes on. It goes on and on and on and on. And these numbers, there's no pattern to them. And if you remember from the section before, where we had to kind of look at some patterns, these ones don't have a pattern. So if there's no pattern, there's no way to figure out what the 50th term is or anything like that. So these numbers are irrational numbers. They're the ones that are not rational, if that makes any sense. So with that in mind, okay, we have the real numbers. The real numbers is the set of all rational or irrational numbers. So the real numbers is both of these, if that makes any sense. And that tells us that a number in the reals has to be either, if it's not rational, then it's irrational. If it's not irrational, then it's rational. So it has to be one or the other. Okay? All right. Hopefully you got that. If not, I would definitely recommend reading a little bit more about these number sets. We're not going to go too much into them, but I do want you to know what they are. Okay? Let's go ahead and use the information we just saw to do these two examples. So first example says, use the roster method to write the set of whole numbers less than 4. So in case you forgot what the whole numbers are, they are right here. Okay, they're right there. It's 0 going up forever, whole numbers. Okay, so they want us to list the numbers that are less than 4. So first of all, the roster method means I'm going to have to put those little curly braces. Okay, numbers that are less than 4 are going to be, let's see, 0, 1, 2, 3. That's it. So all of these elements, 0, 1, 2, 3, are less than 4. Done. Second example, use the roster method, so there's my curly brace again, to write the set of integers between 2 and 8. Okay, so now we're talking about integers. So I'm going to scroll back up again so we can see what integers are. Integers are these ones, the ones I pointed to earlier, denoted by the I. Okay, and it's pretty much every negative number, 0, and positive number that's a whole number. So it's kind of like the whole numbers, but it also includes the negative numbers. Okay, so they want us to include the integers between 2 and 8. So it says between, which means I'm not going to actually include 2 and 8. So I'm going to start with 3. So 3, 4, 5, 6, and 7, and that's it. Because if I put 2 here, that's not between these two. I'm sorry, it's not include. It's included, and we don't want to include it. Okay, it just says between them. So that's it. We included all the numbers between those two numbers. All right, moving on. Because remember, this is going to be a somewhat lengthy video. We have another definition, and this kind of ties into some of the stuff we did earlier. A well-defined set. So now we're talking about something that's called well-defined. Okay, is a set where each element can be determined indefinitely. So what that means is that there's no how could I say this? Like there's only a certain number of numbers that are going to fit in there. So for example, this one that we just did here, okay, 3, 4, 5, 6, 7. It has exactly 1, 2, 3, 4. It has 5 elements. That's it. We can tell exactly what elements they are, and there's no ifs, ands, or buts about it. Okay. An example of a set that's not well defined. Okay, so I'm going to give you one like that. Maybe that'll kind of clarify. If I said the set, not a set, we'll say the sets of greatest movies. Okay, so the set of greatest movies. Your key word here is going to be that greatest. It's kind of like an opinion thing. My definition of greatest movies is definitely going to be different from your definition of the greatest movies. So therefore, this is not well defined. Okay. Whereas if I said instead, Okay. The set of let me see what's a popular movie franchise. Um, well, let's just stick with Harry Potter, I guess, because I can't think of anything else. The set of Harry Potter movies, that would be well defined because we know exactly, well, we can look it up anyway, in case you don't know. I know which ones they are, but I'm not sure if you do. This one is well defined because we can actually look this up and we have a number of what those elements are. Okay. There's no there's no debate on, oh well, that Star Wars movie, I would consider it a Harry Potter movie. It doesn't work that way. It is or it isn't. Okay. So that's the definition of well defined. Okay. I'm gonna go ahead and move on. So we have a few more things.